Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode we're going to be solving a lot of sums in the topic of probability. So in the previous episode we talked about probability, about the concept of probability. So if you haven't checked it out, then I can check on that episode. But in this episode we're going to be talking about solving some of the sums of probability. So without any further ado, let's solve some sums, shall we? So I got some sums right here and let's solve them. Okay, so the first sum is, which of the following experiments have equally likely outcomes? Explain. So we have to explain which sums have, which of the following sums have equally likely outcomes. Like I said in the previous episodes, equally likely outcomes are the outcomes which have equal chances of happening, kind of like flipping a coin and expecting head or tails. So, a driver attempts to start the car starts or does not start. Now this is not an equally likely outcome, most likely, because there are a lot of important things and important factors that depends on starting a car. So for example, it depends whether the fuel tank is full or whether the fuel tank is empty, whether the temperature is hot or whether the temperature is cold, whether the car is a new one or an old one, etc. So no, it does not have an equally likely outcome. A player attempts to shoot a basketball, she/he shoots or misses the shot. This is also not an equally likely outcome because, well, there are again a lot of factors depending on it. Whether how he threw it, where is the hoop, who is the player, what is his track record, etc. Next, a trial is made. The answer is true or false question. The answer is right or wrong. This has an equally likely outcome because the only outcomes over here are true or false. Next one, a baby is born. It is a boy or a girl. This also is an equally likely outcome because, like it says here, it can be either a boy or a girl. Next one, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? So, like I said in the previous episode, tossing a coin is considered to be a fair way of deciding which team should get the ball because when you flip a coin, it has an equally likely outcome of either getting head or tails, so that no team can get alienated or no team can feel as if they are biased. So that is why tossing a coin considered to be a fair way of deciding which team should get the ball. Not only in the beginning of a football game, but it is also used in cricket games, etc. Next one. Which of the following cannot be the probability of an event? Option A, 2 by 3. Option B, minus 1.5. Option C, 15%. Option D, 0.7. Now, comment down below what you think the answer is. And the answer is B, obviously, minus 1.5. Because 2/3 exists in the scale between 0 to 1. Like I said in the previous episodes, impossible event and sure event. And 2 by 3 is in between 0 and 1. So, it is a possible outcome. Next is 15%, which is also between 0 to 100%. Next is 0.7, like I said, is between 0 and 1. But on the other hand, minus 1.5 isn't, because minus 1.5 is before 0. So the answer is B. Next, if P of an event is equals to 0.05, then what is the probability of not E? Now, like I've said in the previous episodes, well, basically to find this out, I said that the probability of an event E and the probability of an event not E is equal to 1. So this is just an example. E plus not E is equal to 1. So when you want to find out the probability of not E and you put it this way, the answer will be 1 minus probability of not E. Or when you pull out not E that way, it becomes probability of E, or 1 minus probability of E. So to find out the probability of not E, what you need to do is 1 minus 0.05 is equals to probability of not E, which the answer will most likely be 1 is 0.95, I'm pretty sure. So yeah, the answer is 0.95, and that is the answer of P not E. So let me rub the board again, do more sums. Okay, so the next one. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy? Well, like the question suggests, there is no orange flavored candy, it's only lemon flavored, so it's an impossible event. So 0. Next one, a lemon flavored candy. As the entire bag consists of only lemon flavored candies, it's a 1, a sure event. Next one, it is given that a group of friends, it's given in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? Again, one, like I said, P of E plus P of not E is equals to 1. So by, substituting the plus to the other side of the equal sign, etc., you'll probably get something like 1 minus 0.992 is equals to answer. So when you subtract 1 minus 0.992, let's actually do it. And let's see, 0.992, 10 cut 9, 10 cut 9, 0, 10 minus 2, 8, 0, 0, 0. So the answer is 0.008. So that is the answer for the question, for this question. Next one. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red? So, let me rub my eye for a minute. So basically, like the question says, a bag contains 3 red balls and 5 black balls. So overall, it contains 8 balls. So the total number of balls are 8. And now let's write, a ball is drawn at random from the bag. What is the probability the ball drawn is red? So now it's time to use the formula. Let me take this. So let's write the formula. Number of trials where the event occurred total number of outcomes. So by using this formula, we can see the number of trials where the event occurred. So basically, the number of trials where the event occurred, where the event is you getting a red ball, is 3. So 3 by total number of outcomes. Since there are 3 red balls and 5 black balls, it becomes 8 balls in total. So 3 by 8. So the answer is 3 by 8 for the first one. And for the second one, again, not red means basically black. So the amount of black balls are 5 and the total number of balls are 8. So the answer is 5 by 8. So the next sum. Oops. Let me put it over here. The next sum. A box contains 5 red marbles, 8 white marbles, and 4 green marbles. 1 marble is taken out of the box at random. What is the probability that the marble taken out will be red, white, not green? So this is a little bit of a trick question, but it contains 5 red marbles, 8 white marbles, and 4 green marbles. When you add them up, you get 17 marbles in total. So now let's take the first question. Red. So box contains 5 red marbles. So the number of trials where the event occurred is 5 for the first one. For the second one, it is white. So the number of the number of trials where the event occurred where the marbles are white are 8 marbles. So 8 by 17. And the third one, you might expect it to be green, but it says not green. So 5 plus 8 is 13. So the answer is 13 by 17. Now, let's do one final sum. A piggy bank contains 50 paise coins, 51 rupee coins, 22 rupees coins, and 10 5 rupee coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin, will not be a 5 rupee coin? So, let's take, using a formula, the total number of coins. So 150 pice coins, so 100, 51 rupee coins, so 50, and 20 2 rupee coins, so 20, and 10 5 rupee coins, 0, 8, 1. So the total number of coins are 180. Now let's say, let's read our question. The next one. What is the probability that the coin will be a 50 pice coin? So the 50 pice coins are 100. So 100 by 180 is equals to, 0 0 cancel, 2 9s are 2 5s are 5 by 9. So we'll also divide them for decimal. 5 1s are 5. Let's say 9 by 5, we get 4. Point here, 5 is a 40. So the answer is 1.8, I guess. So yeah, let's do the next one, which is will not be a 5 rupee coin. So the 5 rupee coin means it's 170 by 180. 0 0 cancel. 17 by 18. Let's say 17 by 18 is equals to, just do the sum, and we'll probably get the decimal. 17, 1, 10. You just kind of do the sum like that. So by doing that, we'll get the decimal value, and that will be the answer. And same like that for the before sums as well. If you get a fraction value, you can actually divide them and get the decimal value. So yeah, hope you enjoyed this video. In the next episode, we'll also do a lot more sums like this, which will get a little more tougher and tougher as usual. So yeah, hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, and see you in the next one. Bye bye.